One more question is KNN a parametric model or non-parametric model? And why is it called in that way?
Okay. The algorithm, the KNN algorithm, does not store or does not learn any pattern in each iteration, right? So it is called as a non-parametric algorithm because it's not learning anything. Every time we try to do the prediction, it uses the distance concept, and then based on the similarity, it tries to predict. Right? So it's not recording any parameters for using those parameters for predictions. That's the answer. It's non-parametric algorithm.
All right. And within KNN, how do you decide on what is the K value supposed to be?
Yes, Bharani. So let me share my screen here. And this is the cheat sheet, you can say, which is specifically done for only K-neighbors classifier. But if I have to talk about the K nearest neighbor algorithm, then I would basically say that it can be used for both classification as well as regression. That means your KNN algorithm can solve non-numeric output problems and numeric output problems as well. This is the first point. The second point that we need to also remember is every algorithm has certain parameters which will allow us to tune the performance of that particular algorithm. In KNN, as the name itself says, K is the number of nearest values to the record. If I have to classify this new record into one of the output categories, then we are going to look at the similarities of this record with respect to the existing historical records. Now, in this scenario, how many closest points should we consider is the hyperparameter that we need to choose. There are certain conditions that we need to look at whenever we talk about classification model, that is when we are trying to define non-numeric values, then KNN method goes with majority. That means mode concept. This is the first point. And when it is able to get the majority, fine, it's very easy to predict that. But if you're not able to get majority, for example, if I have a two-class problem, that means it's a binary problem, then I cannot choose K is equals to 2 or any number which is even, multiples of 2. If I do so, then I might get the closest records which are equally distributed. That means if I have 1 and 0, then I might have one record which is closer to the record, new record, will be from the class 1, and the other record that we have will be from class 0. So this is an ambiguity scenario. So this is one problem that we will have to address. So as a developer, when you're writing your code, KNN algorithm, you need ensure that you don't choose K value, which is multiples of your classes, the number of classes that you have. So not equal to the number of classes, multiples of number of classes. This way, you don't get into the ambiguity scenario and you will get majority. If it is a numeric problem, then depending on the nearest values, it chooses mean value, and based on that mean, it tries to predict for the new record. How to choose the best K? It is an iterative exercise. We will have to try with different K values, try to fit the data with respect to the K, try to do the prediction, capture your metrics, and then identify at which K value we are getting the good performance. And always remember, when we talk about metrics, a lot of participants, a lot of newbies in the machine learning world, they always redefine accuracy only. By default, they fall back to accuracy calculation, but always remember this is not the only parameter. You'll also have to look at the misclassification cases as well, right? And you need to assess the cost of misclassification for each K value that we are trying to measure. Along with accuracy, we also have to look at false positives and false negative cases, assess in what scenario the application can be more practically applied to the business cases, and then choose that respective K value for deploying it onto the production instance. So it's an iterative experiment-based approach, and we can always do automation on hyperparameter optimization. You can use grid search, randomized search, or your Bayesian search. Different search algorithms can be, hyperparameter search algorithms can be used. You can also manually write a for loop for that matter, and then sequentially you keep executing the K with those respective neighbors, and then try and see at what K value you're getting good results. So that's about choosing the K value. And of course, along the way, we'll also try and do other parameter alterations as well.